Welcome to episode 33 of Full Momentum and HEC-RAS podcast. I'm your host, Ben Carey. Here joining me as always, Chris Goodell, and we have, I think, the largest panel that we've ever had on Full Momentum, which is exciting. And I'm going to go through and introduce each one of the gentlemen that are joining us today. Craig Price, obviously you all are familiar with him. He's been on our podcast before. We also have Bill Katzenmeyer. We have Sean Misick and Aaron Nichols, all joining us today. The topic for today, and the reason why we wanted to bring on so many people, is because it's a really exciting topic, but it's also a really kind of complicated topic that a lot of folks that use RAS aren't taking advantage of. But we see the direction of RAS as incorporating the different tools and approaches that each of these gentlemen are kind of specialists with, and that is using AI and automation to maximize the utility of the HEC-RAS program. So that's what our topic is today. We're really excited to have everybody here. Chris, anything you want to add before we go through and introduce each of these gentlemen?
Yeah, same here. Really excited. Thank you guys so much for joining us. We've been trying for several months to pin down a date to get everybody together. It's really hard, and Cray, especially being up well past midnight in Australia. Thanks go to you for joining in. But yeah, this is really, I see you guys here as an all-star panel. We were all on the Australian Water School several months ago talking about this very same thing. And I'll let Craig talk a little bit more about that in a second. But I mentioned you guys are really, I see you as pioneers in this field of AI and automation of HEC-RAS, and really not even limited to HEC-RAS, but other tools that we use in our industry. But I'll speak for myself and say, super grateful to have you guys kind of leading this effort, because this is something we're going to be dealing with for the rest of our careers and long beyond when we retire. And it's not going away. It's going to become more and more prevalent. And I think for the folks who are out there not sure how do we get started with this, we're hoping to give you some ideas today, so it's not intimidating, because I think the sooner you get involved with it, the better you're going to be moving forward.
Yeah, absolutely. And obviously this is a huge topic. We could spend hours and hours on this discussion. We are going to try to limit this to roughly an hour, but fortunately there are going to be a lot of follow-up opportunities for you to connect with these gentlemen, both in this type of a forum, as well as through some of the links that they will provide with tools and stuff that they've already put together. So a lot more to come, both today and moving into the future. But with that, Craig, you want to kind of kick us off and reintroduce yourself to the audience today that's tuning in.
Sure. It's great to be with you again here. Amazing to see what Ben and Chris, what you've put together over the last few years. A lot of wonderful content out there for HEC-RAS users, and I'm just astounded. I'm no expert, so I am not part of this expert panel. I'm an observer. I'm a learner. I watch what's going on, and my mind is frankly blown every time. And what happens is my mind gets blown by what they show us like a year ago, and then a few months later, Bill and Sean and Aaron have come on, and there's like, hey, here's what it can do now. And, what we do as hydrologists, a lot of times we'll plot time series. We look for trends. We look for, we're looking at climate change. We're looking at things like this. If you look at the trend of where this is going, if you just plot it out and see the progress that's going on, imagine where we'll be 10 years, 20 years, 50 years from now. It is frankly mind-blowing, and I hope you'll see that. And again, as Chris mentioned, I hope you get a chance to try this yourself, because it's easy to just watch people do things, but it'd be great if anybody watching this who wants to try it has the resources, which we'll give you here momentarily. We'll point you to some resources that allow everybody, every user, from the absolute beginner, to actually try it themselves and actually get engaged instead of just watching other people do it. Try it themselves. So yeah, let's hear from our three experts here. As the rest of us watch in the background, I see it in the order of Sean, Aaron, and Bill. Maybe we go in that order. Sean, just a quick introduction.
Sorry, I'm on mute.
There's a mute.
My name is Sean Misek. I'm with Fenster Maker and Associates. And yeah, my background is in, hydraulic modeling, and then kind of learned VBA and Python and programming simultaneously. So that's kind of my background.
How long have
And
you been
Sean,
how long have you been using RAS for, Sean?
Since like 2019.
Okay.
And then I got a copy of Chris Goodell's book, and the rest is history.
well, Sean not only has the microphone for it, but he has the podcast voice down. I think probably better than any of us here. So
I know we might have made a mistake bringing him on, Chris. I think we're going to potentially lose our hosting of the podcast here.
You are now listening to HEC-RAS.
There you go.
That's awesome. Well, welcome, Sean. We're super happy to have you.
Yeah, thanks, Sean.
Aaron, you're up next.
Yeah, my name is Aaron Nichols. I'm with Atwell LLC in Arizona. Been RAS modeling since my career started in late 2017, early 2018. Been watching Chris and Ben, for their tutorials and stuff like that. So very familiar with you guys, and appreciate all that you've shared. But yeah, as far as my career trajectory, started out Python programming pretty immediately. And then in late 2022, I heard of this thing called ChatGPT and heard that it could write code for you. And I immediately hopped on that and then just been hooked ever since. So started sharing what I've been learning, and, and happy to keep doing so.
And that was 2022, right? You said?
Yeah, I think it was like November or December 2022. I hopped on it pretty quick. I think it was GPT 3.5, so it was okay back then. And then March or April 2023, GPT 4 came, and basically that I don't program anymore. It does it for me.
Isn't that incredible, though, to think that that was about a year and a half ago, and where we've come in just a year and a half? It's incredible.
Yeah.
That's the trajectory that Craig was talking about, right?
Yeah.
Yep.
Yeah.
Cool. Well, awesome. We're super happy to have you here, Aaron, and excited to see what you have to share with the group. Bill, last but certainly not least.
All right, I'm Bill Katzmeyer with CH Fenstermaker and Associates. I'm the one who put out the HEC Commander repository, and that's been pretty much built with AI. The whole project came about because I was able to code because of AI, where before it was too much of a heavy lift. I think if I had tried to walk the path of the 10,000 hours, I probably would still be on that path today and not have produced anything useful. So, I guess I've done a lot here. Some of it is maybe, I think, from the perspective of a Python master, they probably look at it and go, yeah, that's pretty interesting little portfolio. But for someone who doesn't code, to me, that's the power of sort of what we built. So that's my little intro. And then I guess, how do y'all want to proceed?
Yeah, well, I had just a follow-up question or clarification just for the audience. So it sounds like Aaron and Bill both come from a place where using AI to help you code, versus Sean, it sounds like you actually come from a little bit of a coding background, so have a little bit more expertise in that area. Is that a fair summary?
Yeah, definitely.
Okay, cool. And I think that's cool that we have kind of both sides of the spectrum in terms of expertise, right? And the end result is products developed from both sides of the spectrum that are really useful to the everyday HEC-RAS user, and so that's really cool to see. I always like.
Well, I would say, I'm not a real programmer. I don't know C. I don't know any of the upstream languages, but I'm a Python programmer, which is basically like plain English. And so Bill just got started with the next iteration of that, like a plain English programmer.
Yeah. Okay. Very cool. That's good clarification. So Chris, yeah, I'll pass it off to you to kind of kick off the technical conversation today. And again, this is meant to be just very much an open forum. We're gonna go for about 50 minutes here. And again, we're also gonna have the opportunity to share some follow-up opportunities for folks.
Yeah, and I want to just mention real quick that I think all four of you, right? Sean, Bill, Aaron, and Cray are going to be doing a follow-up Australian Water School on the same topic. Craig, do you want to give a little preview on that and things to come?
Sure. Yeah. Let's do that at the beginning, just so that if you hear something and you're like, wait, I wanted to find out more about this or that, you'll know that there are some resources available to you. So I've got this little website here set up, hydroschool.org/AI. And you'll see here, again, the headliners that you see here today in our Full Momentum podcast will be with you again if you want to register for this one. It says July 31st on the ad here, but that is in Australia, so it's the evening or the afternoon of the 30th of July, just a couple weeks away. Anybody wants to join us for that, and if you're watching this podcast recording later on, then the recording would be on the Australian Water School's YouTube channel at that point. So this is a free webinar, and then there's a deeper dive for a couple of hours specifically dedicated to HEC-RAS AI applications coming up in August. So if you go to this website, you'll find links to these resources, in addition to one that, again, the same team was involved with a couple of months back, and that led into some really cool things for HEC-RAS users. One of the things that you spend a lot of time doing is trying to delineate either aerial photos and things like that, trying to figure out where buildings are. You might see a little preview of a couple of those things today, but if you wanted to get a deeper dive into that, we've got this AI segmentation one that helps for any modeling. It's not just HEC-RAS, it's whatever you use for hydraulic modeling. You spend a lot of your time doing that, and delineating break lines from topo, and getting land use or building edges. Why do it yourself when AI can do some of this for you? You still got to check it, make sure it's right, but have a look at that. And then we've got this Hydro GPT one that's specifically about Chat GPT. It's a little more general, not specifically to HEC-RAS like we'll see in these other webinars, but you may want to have a look at those as well. And then Chris was a part of this one. And if you're at the very beginning of any AI at all, if you don't understand some of the terms that are coming at you with large language models and machine learning, those sorts of terms, watch Dr. Cobra Etbanani's presentation for about 10 minutes. She did just a brilliant, outstanding job of just summing it all up in a very concise introduction that just kind of puts it all at an introductory level. So have a look at some of those introductory resources. We've got flood modeling with AI tools here in another webinar, a bunch of stuff in here. Dr. Wu, we'll have to make a plug for Dr. Wu and some of the resources that he's got. He was able to join us, just a brilliant genius in this front, with a lot of plugins for QGIS and other things like that. It's just endless, this list. But the reason I wanted to show that is because we're going to give you kind of a conversational overview of this, but when you get into it and dive into it yourself, you'll have a lot of opportunities, not just for using the AI to script for you, but we also have scripting. And I guess I'll make a plug back to you, Chris, on this one. What got the Australian Water School started with Python was your introduction to us to Kevin Nebbiolo from our sponsor, Kleinschmidt today, who introduced everybody. Every Python course that the Australian Water School runs starts with his introduction, which was also a brilliant introduction into Python. Have a look at some of those. There's some free ones. There are some paid ones as well. But these links will all take you to those resources. There's a lot out there. I don't want to take any more time. Let's turn back to the experts, and just again realize that there's going to be a lot of other resources for you to latch onto, from any beginner level up to advanced coding. There's something in it for everybody. So yeah, back to you, Chris.
And just real quick, for people who didn't see that, maybe they're just listening. Australian Water School, just Google that, and that'll take you to all of that, right?
Yeah, certainly.
Australian Water School.
And we'll also provide the links to it in the YouTube.
Yep. Well, thanks for plugging the sponsorship, by the way, to Cray and Ben. I'll let you do that officially before we.
Yeah, absolutely. Like Cray said, the opportunity to get everybody together in the same room wouldn't happen without the sponsor for today's episode, which is our firm that Chris and I work for, Kleinschmidt Associates, who are known throughout the industry as a firm that provides practical solutions to complex problems affecting energy, water, and the environment. You can learn more at kleinschmidtgroup.com. So thank you, Kleinschmidt. And with that, Chris, I'll throw it back to you for our kind of first kickoff
So Bill, I want to come to you first. Okay. So
Okay.
this is about AI automating HEC-RAS. Let's imagine somebody is a HEC-RAS user, but maybe they haven't really been following. Maybe they don't even know what AI is. Why should they be interested? Give us a quick summary, general overview about what AI is, what automation is, and why somebody who's a HEC-RAS user should be interested.
Well, the first thing, yeah, I just got back from ASFPM, so I saw everybody there needed to, include AI and everything. I think it's the new buzzword. It's definitely where the hot ball of money is, and so everybody's chasing it. But I do want to draw a fine line between AI and using large language models, because what we see a lot of is, everybody's kind of seen machine learning. That's gone through a lot of the coursework now. You have people that come out with a formal education in machine learning, but what we're doing with the large language models and applying them is really different than any of that. It's really taking something that's a fully developed technology to a certain extent of having the large language model that's instruct tuned with a very primitive technology stack around it that you're getting directly interact with. And it's totally not the same. And I think the first thing people think is, oh, well, this thing's intelligent. It must be able to like run my model. Maybe I can get it to click on my screen. None of that is actually how it works. And I think a lot of people get lost. The first thing they try to do is ask a few things general about HEC-RAS, or say, I've got a screenshot of a model error and it doesn't really answer the question, or it hallucinates an answer. And a lot of that is just due to its training materials, and that's going to get better over time. But it's sort of one of those things that we have to start building tools and interactions around these, because all these models are tuned for instruction by what they call real life human feedback. And so it's actually going to feed on us using it, and then reviewing conversations and seeing which ones are useful, which ones seem to, generate a positive feedback from the user, and take those and learn from them, which, if we get stuck at nobody wants to touch them because it doesn't do anything useful for them, then we never really get down that path. So a lot of it really is using it. And in fact, I've seen even for some of the things I do a lot, it's gotten much better. And I work in my personal account as much as possible, where it can train on the things that are not proprietary.
So
for
just so everybody's aware too, I want to make sure that everyone's following. When you're talking about large language models, you're talking about ChatGPT, you're talking about Bing or Copilot. Sorry, Microsoft Copilot. There's some others out there. I think I heard some. Yeah, some of you guys have some others that you might prefer, but basically we're talking about those kinds of things, right? For large language models.
Yes. Generally, ChatGPT and Claude, and then anything by Microsoft that's a Copilot based wrapper. You can't always depend on them actually serving you an OpenAI model on the back end. So those are useful. You sometimes get OpenAI, sometimes you can kind of get a cheaper model that they try to switch out.
Yeah.
Bill, I'm glad you brought up ASFPM, because one of the observations that I had from that conference, which if anybody hasn't gone to, is awesome technical conference, especially if you're an HEC-RAS modeler. But I think especially sitting next to Bill during a couple of the presentations, not only do you realize that there's more and more folks that are showing these tools in practice from a consulting standpoint, and how tied they are becoming to kind of high level HEC-RAS modeling, but it also starts to kind of highlight some of the presentations or projects that didn't include that. And you start to kind of observe some of the inefficiencies or the potential to make their project or their process quite a bit more efficient without that component. So when I went 2 years ago, there was a few smattering of presentations on automation and how that helped the process, but it seemed like this year there was a lot more. And that certainly, I know you made a few comments about certain projects that really would have benefited from the tools that we're going to kind of discuss today a little bit.
Yeah. Well, let me ask the group, feel free to jump in, but why do we even want to automate? What's the purpose behind that? Specifically HEC-RAS. Why do we care about that? I'll step in
as a user. When I look at my consulting rate and my time spent, I spend a lot of time doing things. I'm a sole proprietor, and so I have to do everything on the model. I don't have anybody else helping me out, and I'm not going to go hiring somebody who, I don't have a steady stream of work. And so if there's something that's just automated, I'll spend hours and hours just clicking and delineating on things. And it's really, it can be a time saver, and it can sometimes be more accurate, sometimes less accurate, but I'll let the others feed in on how useful it has gotten lately. But to me, it's time saving.
So I think, why do we care about automation? HEC-RAS has a ton of tools that they've added through HEC-RAS Mapper and all of that are awesome. But each of us and each of our firms, and just as individuals, have little differences in the way that we work. And if we had the ability to create a tool, we would do that for ourselves and just use it ourselves. So that's where these large language models can be used. They can be used to develop the code to your very specific thing that you want to automate. If that's something that you use over and over again, that's worth it, because you can save time there and focus on the higher level stuff that takes critical thinking, not the kind of routine manual tasks that don't really use that higher level thinking.
Yeah, when I hear automation, I immediately think programming, right? I mean,
Yeah.
You're going to have to learn a little bit about programming. Sean, what's your experience with that? I know you've got some maybe more formal training than the rest of us in programming, but how do you see that interacting with RAS and automation?
Yeah, so I mean, your book kind of lays out the different ways that you can automate RAS. Like they came out with a simple COM API that you can use VBA or Python to automate a couple of like very limited functionality for that. And it's a little dated now with 2D. But all of these file types that they use in RAS are either like an ASCII text file, which, I mean, you could paste that into a large language model and help it parse, or, HDF, some other open standard, and then, decreasingly DSS, which has enough tooling that you can also interact with that.
Yeah, and speaking of that book, back then there was no Python available. At least I didn't know about it, but I had Excel, and everyone has Excel, and inside of Excel is VBA. And so it's really, there's a low barrier of entry to get into coding. Even if you don't know Python and you want to try some stuff out, just open up Excel, get into VBA. But I think everyone here would agree that if you want to take it to the next level, you kind of have to get into Python or another maybe more sophisticated language than VBA.
Yeah.
Chris, I think a lot of people who have been using HEC-RAS for a long time, they know breaking the HEC-RAS code, but there's a lot of new users. When we talk about the book, it's obvious to everybody what you're talking about. Maybe make a quick plug about what people should Google to go look it up. And is there another edition coming out?
Okay, I definitely did not organize this to plug my book, but I appreciate you guys doing that.
We'll do that. We'll do that for you.
Okay. Yeah. So, yeah, if you just Google breaking the HEC-RAS code, you'll find it. If you have any trouble, just get in touch with me and I'll help you out. Yeah. And as far as a future version, I'll just say that it's in the works, but I don't want to guarantee any date because I am extremely busy these days and it's hard to put time into writing a book. But I'm hoping that at some point we'll have another version that's more
Chris,
updated. Yeah.
Chris, I heard that Bill was coming out with the second version. So is that not?
Hey, you guys want to, yeah, feel free.
Are we commanding the HEC-RAS code? I don't know.
Please, yeah, share knowledge. Absolutely, yeah. So,
Hey,
but yeah, I mean, these days Python is a much more useful tool for it, especially when you're dealing with HDF files, which it seems to be, that's where RAS is going, as everything is being stored and read and written to HDF files. So, I kind of want to know, Bill, about your experience, or actually I know it a little bit, but I want you to tell everybody, because I was floored when you told me that I think 2 years ago, you'd never done any coding. And you got onto a large language model. I mean, correct me if I'm wrong, but maybe you start with ChatGPT and just started asking questions about how to write code. And next thing you know, you've got code out there that are people are using to automate HEC-RAS. So tell us a little bit about that.
Uh, well, it really started with ChatGPT, GPT-4. I think Aaron used GPT 3.5. It for me being sort of reliant on it to do a lot of coding. 3.5 wasn't enough. It wasn't accurate enough to really do anything in production, and so I never really used it for that. And also, the tools didn't exist. ChatGPT came out. They immediately released Code Interpreter, which allows ChatGPT to basically execute code in a sandboxed environment right on the website. And that really gave me the idea of, oh, well, now they're amassing this huge data flywheel of Python interactions that are bespoke, that like meet people's immediate needs. And so that is quickly going to make this a very, very capable model for this. So the natural way to extend that is to bring it into a local notebook. And so I started by just kind of what Sean mentioned, just taking the inputs and putting them right into the large language model and saying, hey, this line I want to change to this. I want to do it programmatically. And then then you sort of move up a level of complexity and say, okay, well, I need to build a pandas data frame that tells this how to do three things, and here's the input data. Now take that and write it to file. Well, you can get it to do all this inside of the website, mock your code up, and just change the paths. And so once you realize they can do a thing, it may do it pretty sloppy, and it might be very close to like a boilerplate example online at first. But isn't that how we generate our own code a lot of times? Before you're a natural at it, and you've got a lot of memorized examples that you can shape into something like in a final form immediately. Generally, you copy paste in a bunch of examples, and you kind of look at it and go, how do I solve my problem? Well, with GPT, you end up asking questions, you get some boilerplate results, and then you start telling it what about that is not what you need and what you need changed. And pretty soon, within the context window of ChatGPT, you've got something useful. Then you can start to build those in a Jupyter notebook. You've got widgets of functionality that you can chain together. And just without having any code experience, I mean, Python is as close to plain languages as a programming language is supposed to be. And so it's really taking it up one level of abstraction. And I made this point at ASFPM in my presentation that I really think that what this does is it brings coding closer to the people who are actual domain experts. So, you can spend time and you can become a Python expert. You can spend your 10,000 hours. It's 10,000 hours you're not spending in your specific domain expertise. It's required to be able to do certain things, but that expands the frontier of what's possible because it brings that coding ability right to a user who's a deep domain expert, and they may not need necessarily very complex things done. It's just the labor effort of having that done is cost prohibitive. Or say for a commercial program or HEC-RAS, there's something that you really need, but it's just not what the people who are in HEC-RAS's ear, or not something that they just really value on their roadmap. How do you get that to work or to happen? Well, a lot of times you had to learn programming and go all the way around. That was never going to happen. So this brings it a lot closer and closes that gap, even though you can't necessarily do production level software with LLMs as they stand right now without deep experience to direct them. So,
but I think it really helps a lot.
Oh, sorry.
Yeah, sorry. Go ahead,
I was
Greg.
just going to ask Bill, is your presentation available online somewhere for people to have a look at?
No, and I need to post it actually. I've been catching up after a week off and then July
All right,
4th.
sorry, back to you, Chris.
Yeah.
Well, yeah, keep an eye on Bill's LinkedIn page. I think that's a great way to keep up with what he's doing. But yeah, it just reminded me when I was working on the McBreach software, we didn't have large language models at that time. And so my mode when I was trying to figure out how to code something was to Google. First, I type in the language I'm using, bb.net in my case. Then I type out how to do whatever and then hit enter. And then you're going to get 30, 40 websites to have to sift through and see if any of those are going to help you. A lot of them are too complex for what you're trying to do. Some of them are just completely, off base. And then you find something that looks like, okay, I think I could use that. And then you got to try and use that and fit it into your code. Whereas now you just get on the large language model, you say, how do I code this? And it tells you and it writes the code for you. You don't have to scour through a bunch of different websites. So
I do want to jump into maybe some examples here. This has been a great kind of opening salvo of conversation. And I know, Bill, you have some slides that you wanted to share. Before we do that, I do want to ask just one more question of the folks. No, you're good, Bill. Regarding, I know that originally when these large language models came out, there was some hesitation around using those to code, kind of the black box theory, right? Where if you don't really understand what's going into it, is it kind of irresponsible as a consultant to use that as a product that actually ends up going into deliverables and whatnot? So I'm curious for especially the folks that maybe don't have the coding background, if you guys have an opinion on that in terms of is there any risk that comes with using those large language programs to help us code in these cases, or do you not really see that?
Yes, I agree. And actually, I'll go back a slide because one of the things that is fundamental to how I approach this is that I like to get the large language model to generate code, and then I've gotten to the point where I can read the code pretty well now and be able to debug things. I don't want to go through the process of actually typing it all out. I save a lot of time. I'm much more attuned now because what I've did was immediately turned around and asked the large language model to explain the code. And to the extent that it's correct, and I was able to pick up then what was wrong a lot of times right in the plain language description, and then provide plain language corrections back that are then transcribed into code. And you do always have to check your inputs and outputs on everything. So I do think that's a very important point. I think it's just the same as using Excel. I think early in my career, I hope maybe my first boss will be on here, and he would be over my shoulder with his reverse Polish calculator, doing everything that I was doing in Excel because he didn't trust it. And it's just really a problem that in the industry of moving to these things that take you away from the pure math. And so I think it's the same thing. You're always responsible for checking your inputs and outputs. And fundamentally, as long as we do that, we have transparency, which code is transparent as long as you can then interpret it. And the interpretation is done by the large language model. As these get better and better, you'll be able to trust more and more that when it says it does something a certain way and you observe the results, you should be able to then introduce enough checks through the process to make it transparent what it's doing, or even at some point be able to trust that it just did it because it was a simple enough operation. So that's a good point, and one that comes up often. I do want to just share real quickly, what can we do with HEC-RAS automation? This is what we did with RAS Commander and HMS Commander inside of our West Fork model, one of our hubs for our Louisiana Watershed Initiative efforts. And each one of these graphs is a sensitivity analysis for a different parameter. And so we have so much uncertainty to these models that parameter sensitivity, just understanding them is just really huge. And I think, I like to think a couple of steps ahead and say, well, who's out there really training an AI on HEC-RAS outputs, or even something, say, more fundamentally physically constrained? If they're going to do something like that, they're either going to have to go to the cloud, go to containers, or they're going to need some way of creating some, data sets that are medium sized. Well, that's what RAS Commander can hopefully do. Set these things up, give you parameter variations, and then give you, even if your AI, your machine learning model is just probabilistic, it'll still give a plethora of results to give you probabilistic answers where otherwise you might not have been able to achieve that. And then just like very quickly, just like what does the future look like? Just lowering barriers to code. I want to just really, really quickly, we talked about going out and finding things online. I made a river modeling forum assistant actually, and I crawled the Kleinschmidt forums and pulled down all of the forum posts, questions, answers, comments, everything except for the images, because you can't process those efficiently in an automated way. Put them all in a JSON file, made it available on a GPT. So it's something I'll follow up, something we can put in the show notes. But this is for everybody. It's also going to point you to specific threads or vodcast episodes to watch to get more information about a specific topic. Now, one of the fundamental limitations of all these is that you have a really big corpus of documents. Sometimes you don't get perfect search over it because it can only return so many chunks. But you can go back and refresh a few times. It's kind of a slot machine of useful information until these things get larger and larger, maybe 5 to 10 years down the road, when we have multi-million token context windows, or maybe billions, where you can kind of almost search half the internet in a single query. But I'll toss it back to the panel after that.
Yeah, well, that's really good stuff. And it reminds me, Aaron, something you showed on the Australian Water School, and something that's really like close to me, which is help sites or how to find help on HEC-RAS. I get a lot of requests for help. I think when I put myself out there with the RAS Solution blog, and Ben and I teach classes, so we interact with a lot of people, and inevitably you get questions back. But one of the things I like to share is with people is how you can go find help yourself online. And Aaron, you had a really cool thing that you showed, which was how to use a large language model to help you find things out of the manual. You want to talk a little bit about that?
Yeah. So I do want to make the point that very recently, and I just want the audience to know that until recently, the free version of ChatGPT was using 3.5, which is only okay at best. The GPT-4 model and now the GPT-4o model are free. So if you haven't used it in a few months, go back to it. There's a lot more features. Try uploading some data, and you'll see some of this code interpreter stuff that we're talking about. You can upload, so answering your question, you can upload documents now. Mm-hmm. And if you want to ask questions about those documents and have the answer from the question not just be from its general knowledge, but be from that source document, it can do that now. It also has web search, so if you want its answers to be tied to sources on the web that you can go and verify and click the links to check, that's available too. This video or any YouTube video now, you can also chat with using Google's Gemini. So there's a lot of new use cases with using AI for that sort of question and answering stuff that helps make it more reliable than it would have been if you were using GPT 3.5 and its sources were just based on its general training data, which sometimes are hallucinated. So this helps ground its answers with some sources that you can verify.
Well, how do you do it? I mean, let's say I've just opened up ChatGPT 4 or Gemini or something, and I want to have access to the HEC-RAS manual and be able to ask it a question in regular language and have it tell me, something from the manual. What's the next step? How do you do that?
So you grab those manuals and you drag and drop into ChatGPT now, as of a couple months ago. There are limitations, and you should be aware of them. Bill and I spent a ton of time talking about it because we think it's important. It is not capable of reading the entire document and then providing you an answer because of the limited context window that Bill mentioned. So what is happening then? It's using your question as kind of a search query through the document and then pulling chunks of text that it thinks is relevant to your question and then supplying those to the large language model, saying, this is the user's question. Here's the reference material as chunks of text. Now provide your answer. So that's how that works, and you should be aware of it. There are known limitations to that. Maybe it didn't grab the right chunks of text. Maybe it didn't ask the question clearly enough. So to address that, other large language models like Gemini, Gemini Pro 1.5 specifically, or Claude, have very large context windows where that isn't an option. You upload a document and the whole thing gets thrown into it and it references the whole thing. So I actually prefer that method for most things. If you're asking like specific targeted questions, like what's the end value of a concrete channel or something like that, and that has a very specific answer, that might be okay with ChatGPT. But if you're asking something like, I want to fully understand, this entire report and kind of the key points and stuff like that, then I would go to one of the other ones. I would go to Gemini Pro 1.5, that one specifically, or Claude. and go that route, because those two will reference the entire text before answering your question. So
Yeah, and when you say drag it in there, you're talking about you get the PDF of whatever manual you want to use, and it's just like dragging into a Windows Explorer folder. You just drag it
Yep.
into the GPT on the interface there, and then ask your question, right?
yeah, yeah. So that will be specific to that individual chat. If you want something that you can go back to over and over again without having to re-upload documents, that's where the custom GPTs come in. They have what's called a knowledge base, and the knowledge base is really you just upload whatever documents you want. I think there's a limit to it. There's some limit on it, but it's pretty high to the amount of documents you can upload to it. But once you do that, every time you go to that specific GPT, I have one of them with all the RAS documents uploaded to it, which I can provide a link to. But every time you go to it, every time you ask a question, the answers are going to be pulled from the document. So just a way to ground its sources for its answers.
Yeah, very cool. Ben, you're on mute.
Aaron, this might be a good point to transition. I think you had some slides or some stuff that you wanted to share screen-wise.
No,
sorry. I think
That was Sean.
Sean. Yeah.
I think Sean. Yeah.
So Sean,
Yeah,
this might be a good
Yeah,
time to jump into
definitely.
that.
Yeah, I mean, so I guess kind of going back to the question of why automate, what can you do with that? I think that Bill is kind of a very rare case where he knows exactly what he wants to do. He just never had the interest to really get into like the syntax of programming. And so he can just hop on these models and he's like, oh, finally, I know exactly what I want. Let me just tell it and get started. But I mean, for me, I'm kind of the opposite, where I need to understand a tool first and then kind of build use cases around that. And so, yeah, kind of just wanted to give a quick demo to give people a little bit of inspiration about like what's possible with programming and HEC-RAS, especially now that, with the outreach from Bill and Aaron, they've kind of given you a jetpack to get started with coding or coding in multiple languages much easier than ever before. So can everybody see my screen here?
Yeah.
Yep.
Yeah, so this is a model that we're working on right now. This is some hydrology where we're doing 35 different variations of design storms with a realistic rainfall. And so, for this example, the runtimes are 4 hours long, but some of these are going to be, we have bigger watersheds and we're going to need to run these for longer. So runtimes are going to look more like 10 hours apiece. And so, how do you accomplish this if you have 35 runs? Traditionally, we would, run these one at a time overnight. But then you're looking at about a month of runtime in order to finish these. And for anybody who has ever calibrated a large model or stabilized a big 1D, 2D model, you kind of feel the pain of just how long it takes. And if you need to change something, right, you need to change one thing in the geometry. That's another month that you have to rerun these. And so, Bill was kind of instrumental in kind of figuring out the architecture of like some of these protocols. But basically, we have access to like a couple dozen machines, like just Windows desktop machines at the office. And each of these has 8 cores on it. And so it's around like 200 cores that we could use for running models. And so we, sometimes we push these to, run a script and push these out to different machines. But there's a lot of coordination between everybody who's using the machines. You have to, log on and this and that. And so we kind of, took it a step backward and thought like, how could we, come up with a smarter system to kind of schedule these runs and, manage these resources and kind of visualize that, as well as, take it completely abstract it completely away from the coding so that everybody on our team can, use some of these scripts to push out a bunch of runs without having to touch the command line or the IDE. And so this is kind of an internal app that we've been working on. Um, and so this is actually pulling from a folder on my desktop. These are all the models currently inside that folder. And so yeah, just select this one. And then it's actually scraping all of the plans inside this model. And so you can, just select one by one which ones you want to run, give it a unique name. And yeah, it's called the Brunner Runner because it runs Gary Brunner's software. It's got the unsteady flow running man there. So you pick a min and max number of cores for each run. Go ahead and start it.
And this is live. There's a closet somewhere in Lafayette, Louisiana that just had a bunch of hair dryers turn on.
No, this is actually from yesterday. So this is a 4-hour run, right? And so, we didn't want to extend this by 4 hours, so did a pre-recorded video and we can kind of zoom through. But yeah, you can tell it's going fast because he's really moving.
Does it have any sort of progress reader or anything like that?
Yeah, so it started launching them, but now it's so for any nerds out there, this is a fast API Python backend with a JavaScript React front end and then a MongoDB database. And so this is kind of like the progress screen here. So we can see it deployed all 35, and you can see each one pop up here. So it populates the name of the model, the run suite name that we gave it, and then the plan name. And so as these pop up, they're kind of tiny. And so I put a little running man emoji so you can tell when a new one appears. But yeah, so basically what this graph is looking at, I kind of modeled this after the Dask distributed task graph. For anyone that crunches numbers, that's the most satisfying way to do it. But basically, on the x-axis, you have the real time, and then the y-axis. These in between each lane, each of these lines that represents a machine. So like this is machine 3 of our. It's not really a cluster; it's just some desktop machines, and then the width of each of these is seems to okay. Yeah, the width of each of these is like how many cores it's using, right? So each of these is one core. If you ran one with 8 cores, it would be like a big fat line that fills up this entire thing. And so we can kind of visualize the whole system at a glance of how much capacity is left in each of these machines. And then it has a kind of like a scheduling system, like a queuing system, basically, where if one person cannot push runs to more than 80% of the system capacity at once, and then it's Fast API is async out of the box, and so different users can come on and push their own runs in, and it'll check the capacity and put them where they can go. And if there's not enough capacity, it'll wait until some of these finish. So now it's slowly populating each of these 35 runs. It's basically copying all the model files over to the different desktop machine and then launching RAS from there.
So Sean, these are all machines in your office. Is that correct?
Mm-hmm. Yeah.
And so they are other employees in your office, their machines, when they're not being used, you can take advantage of them, or
yeah. So the idea behind it was, to not have to log on through the RDP protocol and like take over someone's machine. But we have a few extra machines, and then we have a lot of people that do more like low compute workflows throughout the day. And so, they could say, take one or two of my cores, and then you could silently push, runs across there. And for our workflow, like our workload is very disjointed, right? Like sometimes we'll be, one person will need to run a lot, and then someone else wouldn't. And so in this demo, some of the runs started finishing up. So we're going to go ahead and open this up in HEC-RAS. And so the rest of them are still running, the other 33 or whatever. But you can see on the left here that some of the results have populated. And so, as a coder, like I used to do all this stuff through code and have to manage, keep track of like where these files are, when to bring them back. But when you write enough code, eventually you can go back to the GUI and it'll just populate everything back to that same HEC-RAS folder. So yeah, you can see that there's some results in there that pulled from another machine.
So when you're using somebody else's computer, let's say maybe you have somebody who's an administrative assistant, and so they've got a lot of cores to spare. Do they even notice that you're on their machine or that you're using some of their cores? Or is it done all behind the scenes?
Yeah, it's a non-interactive session. So it's right now we have I think you might see in the video like a command window pop up for a second. So that's how we're doing it right now. But before it didn't have the command window. It just ran HEC-RAS directly. Just slow iterations trying to get the architecture just right in the system. But yeah, so it's been 4 hours in the simulation time, and it's getting through, and they're all disconnecting, which means that the run is complete, and then it gives this little update. This suite complete with 35 runs. And then we can go back into HEC-RAS.
So much of this is just like a great example of what a traditional Python programmer with a full stack experience can do when they're being fed, constantly being fed new ideas and workable code segments that could be refactored and reutilized by people who are right on the models. So otherwise it would have, like Sean would have had to do all this on his own. He would have had to basically do everything I did with RAS Commander and then all of this back end. He was able to focus on the back end and take something that I've actually published for free online. Anybody can jump on and run their models in parallel across multiple machines with a very similar setup. But then this adds something for extra value for our business. It's a proprietary tool, but it's just an example, I think, a great example of what an existing Python developer who may feel like this is encroaching on my space. Actually, it's not. It should take less of this away, make the technology more accessible to your coworkers, and let them, hopefully in the right situation, feed you useful code that lets you move up an abstraction level and a level of value as well.
That's super cool.
Wow. Yeah, that's very impressive. One question I had that came up on one of our webinars just while this is running toward the end, I think, and I forget who it was among our presenters here who mentioned it, but when is it just computers doing computer stuff and doing it really, really well? And it's just, this is what computers do, and computers are doing computer stuff more and more efficiently. And when does it go into AI and actually where it's learning and being trained? I forget, was it Bill? Was that you who mentioned that? There's somebody mentioned that on one of our webinars, and it's like, well, I wasn't sure. Some of the beginners may not know to AI, may not know where to draw the line between, again, computers doing computer stuff and actual artificial intelligence, where there is learning involved and training.
Well, if you're training it, I mentioned earlier, I work a lot in my personal account when there's things that are not, say it's just how how to modify a HEC-RAS plan or something like that. It's very generic, not really proprietary. I'll do that in my personal account. In a way, I'm training the AI. It's using that to learn. But then I guess what you're getting into is like system one thinking versus system two thinking. AI is very much still closer to the system one thinking. The system two thinking is considered emergent, and it's not reliable enough to say, every single time you submit a query, it's going to have that property or even need it. But a lot of times, a lot of questions you might ask have a lot of implicit context. And so when you're talking to your coworkers, they remember everything that you've told them over the course of your relationship versus an AI. Every time you come up to it, it's blank screen. Like you said, computers doing what computers do, but it only knows what it's been trained on. It doesn't really know the context of your conversation unless you tell it. So um, I think one of the fundamental problems people always have is they see something do something well, and then they generalize that to other abilities. And really, until you put your hands on these tools, use them, and try to use them in your daily workflows, and find where they hit a wall, and you will find it quickly, and then find ways where it doesn't. It's what's called the jagged edge. What you may find is that the wall is really not a useful place here, but in a very adjacent use, it does something amazing that you didn't really expect and you wouldn't have predicted if you had only tried the first thing. And so a lot of this is like it's like having the mouse. It's a new thing. You really just need to interact with it, um, learn it, and use it. And through using it, actually, is probably the best way to learn because it is very non-deterministic, and the model's changing all the time, and so are the platforms in a way. And so their capabilities are always shifting a little bit. They add a couple of Python packages, and all of a sudden it can do QR codes, it can do knowledge graphs, it can do who knows what's next. So that'll be the most fun thing. So I think this is maybe the wrap up. So I'll end it there.
Awesome, Bill. So, Aaron, I want to come back to you. We've heard some cool stuff that Bill and Sean have been working on. What are some things you're getting into these days as far as HEC-RAS and automation? Oh, we lost your audio again.
Like the next
I
think you figured it out.
Oh, he's got a hack now to get his audio going. No, still not.
No.
Nope.
So, Craig, have you had any consulting level experience with using automation or AI yet in your world?
Well, yeah, I mean, again, for me, what saves times is the delineation. So I haven't so much got into the Chat GPT type application, but for segmentation and for delineations, yeah, absolutely. And so we've got some of these examples where our presenters here have actually stepped us through the water school. And when we say Australian water school, there's nothing about what we've done with AI here that is in any way specific to Australia. We just happen to have a forum that we use to put this out there. And so on the Australian Water Schools webinars, some of these we've actually gone through, and yeah, they gave us the code and everything else where we'll take an aerial photo and it'll learn, okay, this is a building, but oh no, this is a trailer, this is a semi truck, this is a container, this is a roof. Oh no, this roof was covered by vegetation. Oh, but it's still a roof underneath that. Those are the kinds of things that help me out. And especially there is a delineation tool that goes and delineates brake lines along ridges that has been trained to where people go along there. And most of the time when people have gone this way, they're going to, follow this path. Oh, and this might be a road and this might be a rail and things like that. And some of the brake lines, we've had people use those tools. And I've tried a few of these where you'll get hundreds and hundreds of these brake lines that you would otherwise be delineating yourself. So that's been absolutely astonishing. But I guess going back to what Aaron was talking about before, I didn't even realize until about 2 months ago that you could actually drag and drop things in here. And in one of these demos, they took like this raster image. You know how we all go into like USBR manuals and you're trying to pick something off, or an old nomograph. You drag these raster images in and it'll read the graph for you. And I was like, wow, it's just phenomenal what these things can do. I had no idea. And this is, a year and a half after I first heard Chris give me a call, and he said, "Hey, have you tried this Chat GPT thing?" Remember that, Chris?
I do remember that. Yeah. And we were having a lot of fun with it that day, but I don't even think on that day we had even a inkling of an idea of where this was going, but it seemed like a kind of fun tool. But for those of you who don't know, Cray has a lot of kids. And Cray, I was wondering if you're going to use that Bruner runner thing that Sean was showing us and commandeer all your kids' computers to run RAS models.
They all need computers for school now, and I actually have about eight different laptops sitting around, and that seems like a great application.
Yeah.
I like the little graphic and the Bruner.
I do. I like that
awesome.
too.
The ultimate next evolution of that software will be to start using Gary Bruner's computer to start running our.
Ooh, yeah.
That would be that.
Sneak onto that. Yeah. Aaron, did we get your audio back?
You guys tell me. Can you hear me?
Oh, got it. Cool.
Okay.
So yeah, we were asking, what are some of the cool things you're doing these days with automation and HEC-RAS?
Yeah, so HEC-RAS has a ton of cool tools built into RAS Mapper and stuff already. So it's really just filling those gaps where it doesn't have quite what I'm looking for. So I do a lot of design work, a lot of channel design and stuff like that. And I get asked, for all these different alternatives that I have, okay, what's the cut and fill volume between that, so we can get a cost estimate. I don't know. There's probably something you can do with the RAS calculator to do it, but I just went to ChatGPT. I uploaded my proposed DEM, my existing DEM. It's like, can you write me something that'll calc the cut and fill volume between this, and just give me that?
Kidding me? That's awesome.
So you can keep going back to ChatGPT and uploading it and having it do it, but really what it's doing is it's writing Python to be able to do that. So what you do, you save that code that it gives you, and now you have that code to rerun every time. So I use it that way. And then if there's ever, I've been getting pretty reliable results creating custom geoprocessing tools for like QGIS. So if there's ever something that I feel like I'm missing or could use, I'll go to ChatGPT or Claude. I should mention Claude is very good, and people should try it out. But we'll go to one of those to write, custom geoprocessing tools very quickly, a couple minutes maybe before I have something that works. But that's how I'm using it. I'm just using it to fill in these gaps where it'd be nice to have this little tool here that I would have never otherwise dedicated the time to Google and figure out, that now I can do that, and anyone can.
I think one of my problems, and probably a lot of RAS users out there have the same issue, which is you don't even know to think to ask to do something in ChatGPT. But it sounds to me like this is becoming the default for you guys. If hey, how do I do this, or how do I compute cut and fill or whatever?
Yeah.
You go right to ChatGPT or Claude or whatever you're using. And a lot of us aren't even thinking to do that. So maybe it's just a mindset thing. We've got to kind of shift into, hey, maybe that should be the first thing that comes to mind when you're trying to figure out how to do something.
Yeah, it is a mindset.
Bill actually had somebody just write a report for him, but like people are cheating in school. What was it? What kind of a report was it, Bill? There was some sort of report that you demoed for us, and you said, "Here, write me a modeling summary report for this model." And
yeah. Actually, I think that was Aaron's. That was writing a drainage report. Yeah.
Okay.
Oh yeah, you showed that in the water school video.
Yeah. So yeah, I think it is kind of a mindset thing. It's just something that we need to do. Is we're going to have to learn this technology. You're not going to be able to not use it, but is to know that, but just invite AI to the table for a lot of different things. Of what you're trying to do, and Bill mentioned, is you're trying to map that frontier of what it can do well and what it fails at, and you're only going to find that for your specific use cases by trying it. So what Bill and I try to do is just we share what we learn. Hopefully you can draw inspiration from it, but it might not apply to specifically your exact workflow. But hopefully there's enough there where you can draw, oh, that's very similar to this. Maybe I can do that there. But everybody's got free access to one of the most capable models, GPT-4o. It's got all the code interpreter features now. So upload like some shape files to it and ask it to do some stuff. that you would otherwise do in GIS. You know, upload a DEM and see what it can tell you about it. Take a screenshot of something. So Chris had mentioned this, you know, one day we'll have an over the shoulder AI who's kind of watching your screen and, you know, do you really want to use that end value there type thing? You can kind of do that as it is now by taking a screenshot. And I've done this before, you know, here's the screenshot of an aerial. Here's the Chow Manning's end table. What do you think? Just use it as, you know, don't take its answers and just use them as your own, but, you know, use it as a kind of thinking partner, you know, second opinion. And eventually when we get this newest model, you'll actually be able to do screen sharing and talk to it. So you won't need to do the screenshot thing. You'll be able to just, here's my screen. What do you think of this? So that's coming before the end of the year.
Yeah, I would liken it to like when I learned to program in Python, you know, at first I was kind of looking at simple use cases and it's like, okay, Python has lists and dictionaries and it can do this. But then you slowly realize like, wait, this thing can interact with every file type on my computer. And so, you know, for GIS stuff, for example, like eventually over a period of years, I stopped using the desktop and it's just easier to write everything in Python, and then you never have to do the same thing again. You just run that code again.
I do want to make sure we mention, because we talk about it on some of our online chats, but for somebody who's just getting into this and really just wants to have their mind blown, just like do one thing to absolutely blow their mind. Everybody listening to this podcast has some gigantic or specialized spreadsheet that they use, that a lot of it is taking in data from over here, doing text to columns, reformatting, and maybe like a couple of even sheets just to get stuff in the right format to do something useful. Take that right now, go drop it into ChatGPT. I think in your last episode with your guest, you were discussing with her how she was like, I'm never going to do another Excel graph again. Well, literally just drop it in ChatGPT and have it do it. It uses Matplotlib. It uses the exact same library backend. Now you don't have to learn to use Python to create pretty plots. You just dump your CSV file in and tell it how to change it. Or if you've got something that's, say, you can't use the data solver because, you know, it just doesn't use a good algorithm. Well, dump it into ChatGPT. And you may have to hold its hand. You may have to give it some screenshots or explain, but it can read directly from an Excel file. It's good at that. And
so you could take your Excel file and you can say, look, I want to take my plots to the next level.
Yes.
And I want to have access to everything that's in Python to make really cool plots. And
add
you just
statistical
ask
analysis.
For it. Wow.
That was change the plot type.
Wow, that's crazy. That was Isha, by the way, who was on our last episode talking about Python. So yeah, which is super relevant to this, but that's incredible. I'm trying that.
That'd be, I think, the best takeaway for people listening to this episode of trying to do something immediately. Yeah. I joke that people have done way more in Excel than ever should have been done. And maybe like running HEC-RAS from it is in that list, but I bet you that you could probably ask ChatGPT to write you a VBA script to debug some of your own automation stuff, which would be, I think, really interesting because there's a lot of that. It's out there, and I would be surprised if that's not in the training data.
Wow. Yeah, I think speaking of plotting, like some really low hanging fruit that I found that GPT is good with the Plotly library in Python. There's some others that aren't as well documented, but like that graph in the Brunner runner was Plotly JavaScript. And so you can just upload your data, tell ChatGPT, make me a plot like this, put a call out over here. Can you move that a little to the left? And then you can say at the end, like, export that to HTML. And then it gives you like an HTML document with an interactive plot on it where you can, zoom in and this and that. And then just sign up for an account on render.com or something similar. And you can just host that on the internet for free. So that's a great way to like rather than sending somebody a an Excel spreadsheet with a plot that you can't even like change the scale of it in Excel interactively. You can just send them a link to a website that you just put up.
Very cool.
That's awesome. I think
Incredible.
my favorite analogy from all of these that came out of the last few things that y'all have helped us out with. I don't know, Bill, if you borrowed this from someone else, but I have stolen it and used it a number of times. You think of AI, or you think of your assistant here as you have access to a drunk Stanford grad, very, very smart, but sometimes makes some mistakes. I've used that a number of times. You can talk to it. You can kind of get some responses back. You can use plain English. Sometimes you got to clarify. You had a rough night, but you've got, you've got a drunk Stanford grad at your disposal.
Love that.
Well, I'm surprised you would say that, Cray. I thought for sure you would say a Cal, a Berkeley grad, but
I should have.
So I wanted to ask a few kind of devil's advocate questions, because I think we've spent a lot of time talking about all the positives of this process and whatnot. And I thought of a couple questions that maybe are on the flip side of this. So the first is, we've talked about all the things that you guys have done that's worked in ChatGPT and in this side of thing. Can anybody want to throw out an example of something that they really wanted the automation or AI to help them with from a RAS standpoint and just couldn't get it to work? Are there any examples of that?
I remember Cray, when he first came to us, asked, is there any way we can get this to do break lines for us? and I gave it a shot. I uploaded a DEM and maybe not so great of instructions trying to get there. And it just, it was doing stuff that was approximating that, but it was just so, and it's not the language model doing it, it's the code that it writes that's doing it. So there's that clarification there. It's not the AI doing it, it's writing the code to try to do that. But it just wasn't quite getting there. And as I was trying harder and harder, like, to get it there, it was taking longer and longer to run. And you start running into the execution time limit, which you only have 60 seconds to run the code. So if it's a large data set or something like that, it takes a long time to run, you won't be able to do it directly within ChatGPT. You'll need to migrate to running it locally. So that was one of the limitations I ran into. Trying to do some of the QGIS geoprocessing tools does take some back and forth. Like, you ask it for it, it's not often that it works the first time. So you're going to have to copy the error, paste the error in, you got another error. And then there's a learning part on your side too. Like, giving clear instructions is a skill that needs to be learned, especially when talking to an AI. You're like, yeah, I guess technically I didn't say not to do that, but so you do start getting, very specific, and it's like programming in English, really, is what it can become.
Yeah, Aaron, I would give a tip about the QGIS. The QGIS Python API is pretty sparsely documented, so I wouldn't expect it to do that well. I would give it like GeoPandas, or I use Rio X-Array. I'm not sure how good GPT is with that, but probably Rasterio. It would have Bill's got mixed luck with that, but
yeah, I've defaulted to more, instead of trying to do inside of a GIS like QGIS, ArcGIS, just doing GeoPandas and Raster.io and stuff like that through pure Python. So I have this list of 50 Python scripts for little tiny GIS things that I like, because one, ChatGPT has those libraries in its code interpreter environment. So you're able to upload test data sets and run it and have it correct its own errors, because it can do that. It doesn't often get it right the first time, but it knows, it's able to see the error and then try again. And it does so, for a good amount of time. It will try to figure it out on its own. So that's my favorite way to code with this thing. Is upload some sample data and have it fix its own errors, because it doesn't typically get it right on the first try if it's a complex workflow.
I think this is a great question, because ChatGPT fails all the time. It is part of the process. I think that's one of the things that drives people away from the tool, is they try to do something and then it's not a calculator. So it's not, put 2 + 2 in it may actually come out and say 5 every once in a while. And you just have to accept that. That's why we generate code if we want deterministic behavior. But when we're okay with a little bit of fuzzy math, let's say it's a report and you're just looking for a word that's close, it's going to pick a probabilistic answer. These are probabilistic machines, and they're going to act that way. And one of the things that we covered heavily in one of our courses is sort of what to expect from these models. And the answer is, for difficult questions, writing code is difficult unless it's very boilerplate. I would classify those as like harder than high school level problems. Well, high school level problems, generally high school level logic, can be done at 90% accuracy by the current level of models. So they'll pretty much work almost every time. Every once in a while you'll see an error, but for the most part they work. When you get into the type of work that we're doing that's actually difficult, it's difficult for us, it's difficult for the models, you're going to get down into the 40 to 60% range. There may be things that I get the model to do that I only got it to do on the 5th time that I asked for the same exact thing and just iterated a little bit on my prompt. Or sometimes I don't even do that. I just click the button again. It's the entropy will handle that. And sometimes it's doing what it's called gradient descents. It's like going down a mountain and finding the path. Well, it goes down the wrong path, falls off the cliff. You run it again, it's totally probabilistic. It just happens to stay on the path. And a lot of what you're fighting is just trying to refine it just enough. So I guess the answer is it fails all the time. Expect it. It's okay. That's part of learning its capabilities, but also its probabilistic behavior. Sometimes you'll become comfortable with just saying, just try again. Just come back. Just like you tell a young intern, just come back after lunch. Just show me that again. Try again, and you'll get it. Like, it just really took a second try because it's the first time you've tried to do it. And maybe with a little extra instruction, you're confident that they'll get it. Same thing with the LLM, except sometimes it's so close that just a little bit of entropy will actually flip it from the wrong answer to the right answer, which is it's amazing to deal with technology that acts like that. Again, not like a calculator like we're used to, deterministic.
Yeah,
I think
I'm glad you addressed it like that, Bill, because that was kind of what I was getting at. Is we got a bunch of really smart people here that just talked a lot about all its successes, and you could perceive that to be or mean that this is easy and that it's going to work consistently. And then if somebody goes and tries it and it doesn't work, well, they're like, well, I must be dumb. I can't figure this out. So I'm glad that we highlighted that this is, even for people that are often using it, an iterative process that takes some time, in which the program usually does not work the first time or even the second time, maybe. And it's something you have to be willing to give it some time and work with it. So sorry, Sean, I cut you off there if you wanted to add something.
I was just going to say that chatting back and forth and doing it in multiple steps also helps. Like if you can give it bite-sized instructions.
Oh, good point. Good point.
Yeah. And then another follow-up on that, similar idea, a little different. Cray, you had mentioned, the tool that you had used to create a bunch of break lines, right, along high grounds, and how that saved you a bunch of time. First thing that pops into my head is, holy crap, I've gotten models before that have just way too many break lines, like unnecessarily number of break lines, because somebody spends, all this time like adding these break lines in. It just makes the mesh look like a disaster and makes reinforcing those break lines at times hard. And there's issues that can come from that, from a model complexity standpoint, that oftentimes just isn't needed for what we're trying to do. Have you run into that side of things where the programs or the automation that you're using is so efficient, so effective, that you end up overcomplicating a model that doesn't need all that level of detail?
Yeah, and frankly, I mean, I have to admit, I actually enjoy doing it myself, even though it takes a lot of time. I like delineating watersheds myself.
I do
It's my
too.
Zen time because
It's an
I
art
can put
form.
on music. I don't have to write anything. I don't have to come up. I like tracing things. I enjoy that. And so I don't like a machine having to do everything for me. But frankly, I've got to admit, yes, the free tools had their issues. And the one I'm talking about that can do it, that we presented in this webinar that we did, is actually a paid tool. It costs about $400. We found that one to be doing the trick. The free ones, I did not, just like Aaron, I didn't have very good experience with this. But I guess what I would say here, just, kind of wrapping up my take home from all this is that, you see some experts in the field, and sometimes I got intimidated as a young engineer, seeing people who had 20, 30, 40 years experience. I'm like, wow, it's a little bit overwhelming to think, how do I ever catch up to that? It's going to take me a whole career to get to where they're at. The experts in this field have like a 1 or 2 year head start on you. That's about it. So, if you're starting out in this stuff, it won't take you long if you're hitting this hard and you're hitting it in a smart way and a logical effective way. You can be an expert in the next year or two, competing with those who right now are putting out YouTube videos and getting millions of hits. It's not that far off. And Chris, when you asked me that question, a year and a half ago, it was right when I forget who said they were just coding and just looking up ChatGPT a year and a half ago. Same thing. When you asked me that question, we said, okay, let's do a webinar on this and let's ask the question: could you scrape the RAS solution, blog or the RAS solution videos and their transcripts? And, could that then generate us some answers? And here we are, a year or two later, and we just saw somebody doing it. It's like, yeah, you can. It didn't exist back at the time, but now it does. I mean, phenomenal.
Yeah, that's crazy. Well, hey, we have kept you guys a lot longer than we said we would. So I appreciate all of your time. I'm about to sneeze now, so I'm going to turn it over to Ben.
Sure. Yeah, absolutely. Like Chris said, we appreciate you guys' extra time. I thought that was a great.
Oh, gosh, sorry.
It was great to get everybody's input from different angles. It was interesting how very, very different applications, different levels of experience, but like it seemed like the general consensus is kind of all moving in the same direction in terms of applicability, ways to get started, things to look out for. And so that's great to hear. And I'm really interested to know if there's folks out there that are listening to this video that have had their own experiences and would like to share some of that. You can feel free to leave comments or whatnot in the video here. You also are welcome to reach out to Chris or I directly and share your experiences, because we would like to pass that along to the rest of the viewers on the podcast as well. There's a lot that I think we can all learn from each other with this topic. And obviously, Bill, Sean, Aaron, Cray, appreciate your time and kind of starting the conversation, at least on this channel, and then extending it further here in upcoming educational opportunities. Which, Cray, do you want to quickly just throw some dates on there for people to remember?
Yeah, I mean, if you're watching this in the next 2 weeks after it's been published, then yes, come along to the live version at the end of July, July 30th in the US, 31st in Australia, and we'll get some specific HEC-RAS tools there. Come around a month later for another one that's a deeper dive. Should cost you maybe 50, 60 bucks. It's a paid course, but it's a couple of intensive hours on that. And then if you want to get into general hydrology for any hydraulic modeler, not just specific to HEC-RAS, Bill, you want to talk about that? That's like September, October. I think there'll be a multi-session course on that.
Yeah, that's going to be, and we're going to cover. It's going to be specific for large language models for general applications. So we're going to cover, what we kind of covered in our first webinar, but in a little more detail of the pitfalls, how to use, but then also get into specifically how to modify some of our HEC-RAS and Flow2D input files to do some automation, as well as how to create GPTs of your own. I showed a GPT here. We're going to show how to create those, and also how to create those for specific libraries on GitHub, so that they can you can interact with libraries that say do what you need to do, but you really don't need to learn that whole library. You just really need to learn how to use it effectively in code. Well, how to arm a GPT with that knowledge and do it quickly enough to be able to get stuff done. And then we're also going to cover general HEC-RAS and Flow2D automation, just how to approach it with Python tools. So yeah, lots of stuff coming.
Yeah. And rather than just watching somebody do it, this is a chance to actually get in and make your computer do what you see people doing. Get that command prompt up there, get the little thing flashing at you, drag the stuff in there yourself, and actually actively get into this rather than passively watching somebody do it.
Yeah, I've actually got I've got stuff online on how to use my scripts and tools that are open source and published. My vision for these is to give people the tools to then build their own of those, not to take what I've done and change it or use it, but really to be able to build that back from first principles and from the widgets that are under the hood, because that everybody's going to need something a little different, and I think that's not going to change.
Very good. And then the last question, Sean, Bill, Aaron, Cray, I know you're on LinkedIn. Do all you guys interact on LinkedIn?
I do, yeah.
Okay, cool. Yeah. So if you want to interact and connect with these gentlemen, maybe ask them a question, that might be the best forum to do so. I'm sure they'd be happy to field any questions and give the best answers that they can. So,
Or just follow them and see what they're putting out there, because they're putting out a lot of cool stuff. Yeah.
Yeah.
Yeah, we could put
And
our
this-
LinkedIn's in the show notes.
yeah, absolutely. We'll plan on
Okay.
doing it. So sweet. Well, Chris, any closing thoughts, or are we going to shut this thing down?
One thing, this has been, as was with the Australian Water School episode that we did back then, just very illuminating for me, very inspiring, very high level. I think after this, I'm going to go delineate some watersheds just to settle down a little bit. But I just want to thank everybody for coming on. This was a lot of fun. I'm reinvigorated about ChatGPT. I'm going to go throw a spreadsheet in there as soon as we're done here. And yeah, thanks so much.
Awesome.
Thank you, guys.
Great.
It's been a pleasure.
Awesome.
And
Thanks
who
for the
knows,
opportunity.
maybe in a year from now, there'll be some crazy new developments and we'll have to get the gang back together, which would be fun to talk.
Yeah.
So.
Yeah, for sure.
Awesome. Well, thanks everybody again. This has been Full Momentum in HEC-RAS Vodcast. Until next time.